What is up everyone, my name is Abhas, your ProtoPie expert, and welcome to part 2 of our tutorial on cursor trail effects. Let's take a quick look at what we've built so far in part 1 and what we'll be building in this one. Go ahead and preview the finished one, and you can see that so far we've been able to make this trailing effect, but in this one what we're going to make is this bubbling animation that happens when you stop moving your cursor for a moment. Alright, let's jump into our working file, and let's start by creating a component with one of these ovals, since these are the kind of ovals we'll be using in the animation as well. I've gone ahead and selected the main big one. I'm going to go ahead and press Command D to duplicate. I'm going to give it a name of oval animation. Press enter and then press the component button here, and that gives us our component. In the properties pane on the right, I'm going to click go to main component. I'm just going to go ahead and make the background darker so that it's easier to see the oval shape. And in our layers panel, I'm just going to go ahead and rename the first oval to just oval, just for convenience. Now, just like in part 1, I'm going to go ahead and create the first variable, which is going to be timer. And I'm going to press the debug icon here to be able to see it on the artboard. And I'm going to go ahead and add a start trigger, which is automatically going to come into effect as soon as our prototype loads. And then I am going to add an assign response, which will help us assign a value to a variable of our choice. In this case, this is the timer variable. And in our case, the formula that we want to apply is timer plus 0.1. So this is just going to keep incrementing the timer variable by 0.1. Since you want it to happen infinitely, we're pressing repeat and then infinite repeat. Set the interval to a bit shorter, maybe like 0.1 seconds. And with this, we have our basic framework ready. Let's go ahead and add the detect trigger, which is going to make use of this infinitely changing timer value. So for detect, it comes into effect anytime there's a change in the specified layer or variable. In our case, it's the timer variable, which is going to keep getting updated every 0.1 seconds. And now for the animation part, this is going to be a fun journey. We're going to make our animation with math functions, and it's going to be super fun. So let's go ahead and press the plus icon here and add a move response. We want to move the oval layer, so let's just go ahead and select it. And this is where the math begins. So for the X position of our oval, let's expand this by pressing the formula button. And I'll just write sign of timer. Now timer is a continuously changing variable, so the sign of timer is also going to constantly change. So let's quickly press OK here. And just to be able to show you what the sign function looks like with timer attached to it, I'm going to create a new variable. Now you don't need to do this, but you can gain visibility inside of this function by doing this. So let's just call it ST for short for sign of time, and click the debug icon so it's visible. Just drag it a little bit down so that it doesn't overlap the timer variable. And since it's a variable set only in this scene, we can apply a formula directly. So check use formula here, and then just input sign of timer and press enter. So now let's see what's going on. Now you can see as the timer value is incremented by 0.1, our sign function is going from -1 to 0 to 1, and then so on and so forth. That's what the sine curve is. And since we've set the move position of this oval to follow this sine function, it is going through that very minor difference between -1 to 1. So it's very difficult to observe this minute motion. So let's start by amplifying this motion. Let's go ahead and go back to our move response. And to amplify this, let's click this here, expand it so we can see. To amplify it, let's multiply by 10. So what was earlier going from -1 to +1, it will now go from -10 to 10. So now you'll be able to see this effect happening. So now you can see that the oval is going from -10 to 10. It's still not as pronounced, but if you wanted to do that, we would go back in here and then multiply it maybe by 100. Let's preview again. Now you can see that the orb is going from -100 to 100, so it's super easy to see this motion now. Why don't we go ahead and copy this and then paste it into the Y position as well and see what that does. So let's click preview and see now that the motion seems to be diagonal, and that's because that's the graph for x equals y. In our case, they're both the same. So in order for us to add another element of motion here, what we can do is shift this sine value through some amount of phase. And an easy way to do that is just replace the sine with cos. So that begins like after half of the sine function has already commenced. So now this will give you a very familiar circular shape. You might notice that it's not perfectly in the center, and the reason for that is, let's click the move response, is that this sine function is taking these values to a 0 position or a -100 position, but we don't know if it's working from the center. In order to ensure that you're actually working from a central point of origin, go ahead and select the oval shape. Make sure that the origin is set to center, which tells you that the x and y positions are 12 and 12. So in order for us to displace or move the sine function by an amount of 12, we will just have to go back here and then add 12 to it. So instead of being at 0, which is the left edge, it will now be at 12, which is the center of our container. Just press enter here and then just go ahead and expand this. Add 12 here as well. Press enter, preview. Now it's going to be perfectly centered because we've added 12 to origin. So instead of going to 0, it's going to go to 12. All right, you might still notice the animation isn't super smooth, like it's still a bit jagged. And in order to fix that, what we'll do is we don't need any kind of easing between these different points made by our sine function. So we'll go ahead and change it to linear. We don't need any more motion curves instead of the sinusoidal one that we already have. And then now let's preview. And now you see the animation is super smooth because there's no other motion curve trying to intervene with the sine values that we already have. Now this is the basics of using the sine and cos and maybe even the tan function as you might want to experiment with. And by using the sine and cos and tan functions, you can go ahead and trace a lot of creative paths. For our case, we're going to keep it a bit simple and we're going to use some variation of the circular or elliptical motion by changing certain values in the x and y sine and cos functions. So let me start by duplicating this oval a few times. So since we had 5 pieces earlier, we can go ahead and have 5 pieces here as well. And then I'm going to go ahead and duplicate this move response by pressing Command D 5 times as well. Apply it to all the layers starting with oval 2, and then oval 3, and then oval 4, and then finally oval 5. Again, if you wanted a more pronounced effect with a lot of particles, you can go ahead and add a bunch of more ovals, but I think with 5, I think this is pretty cool. Okay, now we need to give each of these some variations so you can see some interesting effects happening. Let's start by going into the first one. I'm going to go ahead into the x value, and instead of multiplying it by 100, which is too much for our cursor, I'm going to change it to a slightly smaller value, so only amplify by 20. And also, I will multiply whatever timer amount there is by 5. So that gives you an extra amount of variation. And now I'm going to go into the y value, expand this, and also amplify this by 20, but change the timer to be multiplied by 2. Press OK. Now here I'm going to go ahead and change this one and multiply the timer value by 7 and amplify it by 15. Now I'm only using the smaller amplification values because I want it to be very close to the cursor. So 15, and then here I'm going to change it to multiplying the timer value by 10 and amplifying it also by 15. One more change that I'll also make here just to introduce extra variation amongst these particles is I will change this first sine function for the x position to cos. So now it's going to change its path more drastically than the first one that we were editing. Let's go ahead and go into the third one. For this, I'm going to go ahead and use 13 to be multiplied to the timer value and then amplify the entire thing by 16. Press enter or OK. And then for this one, I will multiply the timer amount by 15 and amplify the entire thing by 10. So this is going to give it that elliptical kind of curve because of different amplifications. I'm also going to change both of them to sine this time so that it's again very different from the previous one that we made, to make it more distinct compared to the previous one. Now let's go to the fourth one and change the timer amount to be multiplied by 3 and amplify this entire thing by 18. And for here, we're going to multiply timer by 7 and amplify it by 20. So again, it's kind of elliptical. This time I'm going to also change the sine to cos and this cos to sine. So again, it's going to be very distinct compared to all the previous ones. For the final one, I'm going to go ahead and expand this and multiply the timer by 6. And instead of amplifying by 100, we will amplify by 33. We still want to be closer to the cursor, but this large number will give you like that orbiting effect. So 33. And for this one, I'm going to multiply the timer amount by 3.5 and then keep the amplification at 33 as well, so it's a bit circular. Alright, and we're not going to change the sine or cos values for this one because we've run out of combinations now. Now you can go ahead and plug in very different numbers here. I would encourage you to try out different values and see what kind of effect you can get through those. However, for our example, I found that these numbers worked great, so feel free to use the exact same ones to replicate the effect super quickly. Now let's go ahead and preview what we've done so far. So now you see it's pretty random seeming bubbly motion. However, one change that we do want is all the particles should not be the same size. So I'm going to go ahead here in the layers panel and change the first one to be a bit smaller than our cursor, which is 24 by 24. So the first one is going to be 20 by 20, and the second one maybe a bit more smaller, so maybe 18 by 18. Then the third one can be probably 16 by 16, so I'm following a pattern here, but then we want a really small particle orbiting as well, so I'll make a couple of those. So the fourth one can be 8, and then the final one for our small little orbit can be just 2. Now let's take a look at the animation once more. Now it looks super cool. One more note before I go forward is you might notice that for all of these move responses, for all of these X and Y positions, I've always added 12. And that stays consistent because I wanted to orbit around a central point, which is the center of this container, which is X equals 12 and Y equals 12. So that's why we're using 12 as an addition on all of those. All right, now let's go back to our main scene by pressing this back arrow here. And now we need to make this component also follow our cursor always without leaving a trail. So what I'm going to do is I'm going to duplicate our first response from part 1 of the tutorial and then just press Command D to duplicate and apply this to oval animation 1. It just follows your cursor 1 to 1 always. So now it should consistently follow. You will notice, however, that this animation doesn't seem centered around our cursor. The reason for that is we haven't set the point of origin for the cursor to the center, and we'll just go ahead and do that here. And now let's preview again. And now you'll see that the animation is centered around the cursor. Now the next thing that we want to do is when this cursor moves, we don't want the bubbling to be visible. However, when it stops for a certain amount of time, it should come back and be visible to us. So let's go back to our file, and now we'll need to create a few variables. So let's start by creating a variable for this scene. Let's call this one mx. This is going to store the current x position of your mouse cursor. So let's go ahead and update it by pressing use formula and then press the dollar symbol and then mouse x. Similarly, we need to create one more for the y value. So let's create my. This is going to store the y value of the mouse cursor. So let's go ahead and use formula for this one as well. Dollar symbol, mouse, y. Let's go ahead and press the debug icon for both of them so that we can see them on our artboard. All right. Now we want to check if our cursor stays still in a position for a certain period of time. And in order for us to do that, we need to be able to store the past value of the x and y position of our cursor and see if it matches the current value. So in order to do that, we are going to add two more variables. So this one we could call mx underscore state, and then one more called my underscore state. These are going to hold earlier values of mx and my, which will allow us to check if the current position matches. Let's go ahead and click the debug icon here as well. Bring it down so that it's visible. All right. Now mx is constantly going to be updated with the value of our mouse x position, and my is going to be constantly updated with the mouse y position. But these guys need to get the mx and my values with a little bit of delay, and that delay is what we'll use to compare values. So in our detect trigger, let's go ahead and add another assign response, and we want to assign to mx state the same value as mx, but after a little bit of delay. So this delay is going to be, let's say for now, 0.5 seconds. So if our cursor stays in the same position for 0.5 seconds, that's when we'll start seeing the bubbling. Let's go ahead and duplicate this by pressing Command D and apply the same thing for my state and change it to my. Let's go ahead and add another detect trigger, and this is also going to be on the timer variable. We could have just gone ahead and used this one, but I'm just making a new one for cleanliness and organizational purposes. Let's go ahead and add a condition now. This condition will check if the mx and mx state values match, or if they don't match. So let's first start by what happens when they don't match. So when mx state is not equal to whatever mx is, and let's also add the my value. So whenever my state is not equal to my, we don't want the animation to be visible. So we'll add an opacity response. So let's go ahead and select opacity, apply it to oval animation 1, and then set the opacity to 0. Let's duplicate this condition by pressing Command D. All the responses for it will also follow. And this time, we want to say when mx state is equal to mx, which is going to happen after 0.5 seconds of your cursor staying in a position. And then if my state is also equal to my, then we want it to be fully visible. Now one final change is, as soon as the cursor starts moving, the bubbling should immediately go away. So I'm going to change the duration to 0. And when it stops moving, maybe it can kind of gracefully fade in. So I'll give it a short duration, like 0.1, so it seems a little quick. Let's also make the animation so that the bubbles kind of scale in and scale out. So I'm going to go ahead and add a scale response here and apply it to oval animation 1 and scale it to a factor of, let's say, 10, so it's super small. Move this guy here so it becomes small when the cursor is moving. And again, Command D to duplicate this guy and move this one here and scale it to 100 when the cursor is still. Again, change the duration for this one to 0 and this one to a smaller amount, so like 0.1. And now let's go ahead and preview, and you'll notice that when we're moving, there's just a trail, but when you stop moving, the bubbling animation gracefully just appears, scales in, and fades in. Wasn't that easy as pie? So now for final finishing touches, I'm just going to go ahead and remove all the debug icons from here so that our artboard is nice and clean. And take another look, and there's a trail, and when you stop moving, there's the bubbling animation. Alright, that brings us to the end of the tutorial for the cursor trail effect, and I highly encourage you to try this out with different values. You can get a lot of different effects by changing the numbers or functions here, and it would be really fun to try it out, and I hope you found this helpful. Please feel free to share your question in the comments or use the link in the description, and we'll make a tutorial on that as well. Until next time then.